Hello, thank you for watching this video. So in this video, I'll be doing question 4 of November 2021, question paper Physical Sciences, paper 1. This is the momentum impulse stuff. So let's go. Question 4. A ball X of mass 10 kg is moving eastwards with a velocity of 2 meters per second. It collides elastically with another ball Y of mass 2 kg which was moving with an unknown velocity Vy. See diagram A. Immediately after collision, ball X comes to rest and ball Y moves eastwards with a kinetic energy of 36 joules. See diagram B. So, let me read this thing again. Ball X of mass 10 kg is moving eastwards with a velocity of 2 meters per second. It collides elastically with another ball Y of mass 2 kg, which was moving with an unknown velocity Vy. See diagram A. Immediately after collision, ball X comes to rest and ball Y moves eastwards with a kinetic energy of 36 joules. See diagram B. No problem. So, what they're saying is, here, we have your ball X, which have a mass of 10 kg, right? Is moving 2 meters per second to the east. You can see the compass here. And then now you have another 2 kg ball Y, which have an unknown velocity. We don't know what the velocity of ball Y is, right? So we don't know the initial velocity of ball Y. So these two balls collide. When they do collide, ball X, which was moving at 2 meters per second, comes to rest, and ball Y now Ball Y now have a kinetic energy of 36 joules after collision. That's what they're saying. I think this is straightforward, because you have this kinetic energy of 36 joules and it's towards the east, it's eastwards. No problem. So let's continue. Ignore friction. So we have this diagram, they say ignore any effects of friction. So go to the first question, which is 4.1. What are they saying at 4.1? They are saying, explain the meaning of the term elastic collision. What is an elastic collision? So they want you to explain what is an elastic collision. So, an elastic collision is a type of collision, right, in which the total kinetic energy is conserved, right? So, in your elastic collision, the total kinetic energy is conserved. That means the kinetic energy before collision, actually, the total kinetic energy before the collision, it should be the same as the total kinetic energy after the collision. So, what that means is, if you can find the kinetic energy of X and find the kinetic energy of Y before collision, when you add these two, it should be the same as the final kinetic energy of X and the final kinetic energy of Y. So, which means when you add the kinetic energy of both balls, it should be equal to the kinetic energy of both balls before collision. That's what it means. So, I'll write it down. It's called what? Elastic collision, right? Elastic collision is the type of collision in which the total kinetic energy is conserved. Means that the total kinetic energy is conserved. What does it mean to say the total kinetic energy is conserved? Which means your kinetic energy remains unchanged. It does not change. Which means, if you can say my initial kinetic energy, right, of ball X plus my initial kinetic energy of ball Y, right, if you add these two, it should come out the same as what? As the final kinetic energy of ball X plus the final kinetic energy of ball Y. The point is, if you add the kinetic energies before the collision and add them after collision, they should come out the same. That's what it means for a collision to be elastic. It means the total kinetic energy is conserved, which means your kinetic energy remains unchanged before and after collision. So which means if you calculate the kinetic energy of X and calculate the kinetic energy of Y and add them before collision, it should also be the same as after the collision. That's what it means to say an equation. A collision is elastic. So let's go. Now we move to what? To 4.2. What are they saying at 4.2? Calculate the velocity Vy. So they want you to calculate the velocity Vy, which means the initial velocity of ball Y. That's what they're looking for. We want the initial kinetic energy of ball Y. How do we find that? We're told that ball X of mass 10 kg is moving eastwards with a velocity of 2 meters per second. It collides elastically with another ball, which is ball Y of mass 2 kg, which was moving with an unknown velocity Vy. So when these two balls collided, they collided elastically. Right? So the collision was elastic. That's what it means. The collision of two balls was elastic, which means if you sum the kinetic energies before collision and those after collision, they should be equal. Right? So now we want V initial. What do we do? So we equate these two and then we should be fine. Because we say, okay, because the collisions were elastic, we know that if we say the kinetic energy if we say the initial kinetic energy of X and add it with the initial kinetic energy of Y, it should be the same as the final kinetic energy of X plus the final kinetic energy of Y. So what this means is, if we add the kinetic energy of X, if we find the sum or the total of the initial kinetic energies, it should be equal to the total or to the sum of the final kinetic energies, because the collision is elastic. So if it's elastic, which means the total kinetic energy is conserved, which means it remains unchanged. So this point, what do we say? We say, okay, we want what? We want the initial velocity of what? Of ball Y. So what do? We say, okay, now the initial kinetic is going to be half. This is the initial kinetic energy of ball X. So it's going to be half mass of X times the initial velocity of X, all squared, plus half what? Half the mass of Y times the initial velocity of Y is equal to this. It's going to be half the mass of X, half the mass of ball X times the final velocity of ball X, plus half the mass of Y times the final velocity of ball Y. Right? Because here, this here is this. It's the initial kinetic energy of X. Here, this is the initial kinetic energy of Y. This here, the final kinetic energy of X. This here, the final kinetic energy of Y. That is what you have. So what do? Say half the mass of X, which is what? Mass of X is 10, times final square of the initial velocity of what? Of X. What is it? It's 2, all squared, plus half the mass of Y, which is 2, times the initial velocity of what? Of ball y, which is what we're looking for. Squared is equal to half. The mass of x, what is the mass of x? Is 10. Times the final velocity of x. What is the final velocity of x? 0, because it became stationary after that. Plus, what is this? This is, we have the mass, which is 2, but we don't have the final velocity, right? But this part here is the same as this one. It's the final kinetic energy. So we do have the final kinetic energy of ball y to be 36. So we have the entire part to be 36. Because this is the kinetic energy this here. This is the kinetic energy here. This is the kinetic energy there. So this one as well is the kinetic energy, but it's the final kinetic energy of ball y to be 36. This point we have to solve for this, right? So what do? We say, okay, you punch it in the calculator, it becomes like 5 times 4. This is 20 plus what? This and this, so you're left with Vy I squared is equal to, punch this, becomes 0 plus 36. Right? Transpose this to this side. So you have Vy initial squared is equal to 36 minus 20. So Vy initial squared is equal to 16. Therefore, Vy initial is equal to, take the square root, so plus or minus 4 meters per second. So, you have plus or minus the velocity of, the initial velocity of y is plus or minus 4 meters per second. So, now in that case, we have to take decisions. We can say velocity, eastward velocity is positive and the westward velocity is negative. Right? So, if it's positive, if we take the positive one, we're saying ball y is going east. If we take the negative 4, we're saying the ball y is going west. So what do? We say, okay, we need to decide which direction is this ball going, right? So this is what we're going to do. We're going to say, okay, we have ball x and ball y. Look at these two balls here. If we're saying our 4 is positive, we have a situation like this. The velocity of this ball, of ball x is 2 meters per second. This is 2 meters per second. And if you're saying your velocity of your initial velocity for ball y is positive 4, so this is where your x is, and this is where your y is. This velocity of 4 meters per second, the positive one, is bigger than that of ball x. What that means is, if we're saying our initial velocity for ball y is positive, we're saying ball y is going to the right, or going eastwards at 4 meters per second. And ball x is also going eastwards at 4 meters per second. But now, if you look at them, these two balls will not collide, because this one, which is ball y, is moving at a faster velocity than this one. And they have the same direction. So we have one ball moving at 4 meters per second east, and other ball moving at 2 meters per second east. So this one, which is x, which is moving at 2 meters per second, will not be able to catch up with this one. Right? Because this one will be faster. There will always be a velocity difference of 2 meters per second for both of them. So there will always be a relative velocity of 2 meters per second between them. So if you have a relative velocity of 2 meters between them, which means this one, x, will never catch up with this one, y. Right? Which means now, it only makes sense for this y to be negative, right? It only makes sense for this one to be negative. So that our ball is going to this direction, so that it is able to collide. So that our ball is able to collide with ball y, with ball x. Because now, if they have opposite directions, it's guaranteed that they are going to meet. They are going to collide in this case. So, the one that makes sense is for our velocity to be negative. right? Which means for our velocity to be westwards, so that the ball y going west will be able to collide with ball x going to east. But if they have the same sign, both eastwards, this one and this one will never meet, because this one will always be up front. But now if you change them and take the negative one, which means the ball y is going west, and now it will be able to collide with this one. So I will say that the initial velocity for ball y is equal to 4 meters per second west. Then they will be able to collide in that case. And we're done with this one. So this is west. We'll move to the next question, which is 4.3. So let's go. What are they saying at 4.3? The balls were in contact with each other for 0.1 seconds during the collision. So they're telling you the balls which is your balls, this is your x and this is your y. During the collision, they were colliding here. They were only in contact for 0.1 second. No problem. They're saying calculate the magnitude of the force that ball x exerted on ball y during the collision. So they want us to calculate the magnitude that ball x exerted on ball y during the collision. So they want you to find the magnitude of the force that x, I think I mislabeled them. This is x and this is y here. So they want to know the magnitude that ball x exerted on ball y during the collision, right? In simple terms, I would say they want to know the magnitude of the force felt or experienced by ball y as a result of x. So you want to know how much force is exerted by how much force is exerted on ball y during the collision. So to do this, I'll say, okay, because I'm dealing with forces, I like free body diagrams. Let's draw a free body diagram of the forces experienced by y during the collision. If you draw the free body diagram, you say, okay, this is the free body diagram for y, right? Not x, for y. You know there's a normal force, which is the force of the surface on the object, which is perpendicular to the surface. There's weight, or you can say force of gravity. And also, there's a force of x, right? Force of x on y. So y, this is the free body diagram of y, which is, this is the force experienced by y as a result of x. So this is the force experienced by y as a result of x, or the force exerted by x on y. So this is the force that we're looking for, right? So this force that we're looking for, that is exerted by x on y, it will cause the change in momentum of ball y. Because you know the impulse momentum theorem, that the impulse, right, this is the impulse, is equal to the change in momentum. So your impulse is the product of the force experienced and the time during which the force was experienced, or the duration during which the force was experienced. So now, the force that is acting, which is this force acting on y for that given period of time, will result in change in momentum of ball y. So the force experienced by y for that given period of time will cause the change in momentum of ball y. So which means the impulse is equal to the change in momentum. Which means now the net force experienced by ball y as a result of x, right, for a given period of time is equal to the change in momentum of ball y. Which means now that force acting on ball y for that given period of time will cause a change in momentum of ball y. So this is the cause and this is the effect. So the impulse causes the change in momentum. So what do we do from here? We say, okay, know this. F delta T is equal to M or P, final momentum minus initial momentum, right? Which is the same as F times delta T is equal to mvf, which is m, which is the mass of ball y, minus final velocity of y, minus mass of ball y, minus initial velocity of ball y. So F delta T is equal to m mass of y, take out the common factor, so I'm left with v, final velocity of y minus initial velocity of y. Because I'm saying the net force experienced by y, which is that one there, for a given period of time, for a given period of time, as a result of x, will result in change in momentum. And then now, but what you don't have is, you want this net force, right? You have the time, you have the mass, you have the initial velocity, but you don't have the final velocity. You don't have the final velocity of ball y, but you can find, because you were given the final velocity, the final kinetic energy. You are given the final kinetic energy of ball y, right? So you know that EK is equal to half mv squared, right? So you know your EK was 36, is equal to 36 equal to half m, right, v squared. So you get that your v is equal to plus or minus 6 meters a second. That is your velocity is going to be plus or minus 6 meters. But this ball, you will know it was going eastwards. So if it's going eastwards, it's going to be positive, like we said there. So we're only going to get this. So we know that the velocity of our ball is, the final velocity of our ball is 6 meters per second. Then you substitute these now. So F net is equal to F net times 0.1, right? Is equal to M. What is your M? Of y is 2 kg times final velocity of ball y. What is the final velocity of ball y? Final velocity is positive 6. So it's 6 minus the initial velocity of ball y. What is the initial velocity of ball y? We said it was 4 meters per second west, which means if we say that it's going to be negative 4, because it's going westwards. So it's going to be minus 4 meters per second westwards. Then we are going to solve this equation. I will clean some small space, maybe here, so that we are able to finish that calculation. So what do we say? So this is the continuation of 4.3. We're saying F net 0.1 is equal to, punch the left hand side, that is 10 times 2. This is 20 divided by 0.1 divided by 0.1. So you get that your net force is equal to 200 newtons, right? And it should be eastwards. But they only wanted the magnitude. So here the magnitude is 200 newtons. But if they wanted the entire force, net force, going to be 200 newtons east. And we're done with this question. It's not bad. If you understand your elastic collisions and understand your free body diagrams, it should be fine. And I hope it does make sense to you, as it does to me. Thank you for watching. Cheers.